On August 15th, 1977, an astronomer named Jerry Eman was looking at data from the Big Ear radio telescope at Ohio State University. He wasn't looking through an eyepiece, and he was looking at computer printouts, long sheets of paper covered in numbers and letters. The telescope scanned the sky, and the computer printed out the intensity of the radio signals it received. Most of it was just background noise, a constant, quiet hiss from the universe. But on that day, a printout from a few days earlier showed something different. Eamon saw a string of characters, 6EQ. This was not a message. It was a code for signal strength. A number from 1 to 9 meant a signal was that many times stronger than the background noise. If it was stronger than 9, the computer started using letters. A was 10 times stronger, B was 11, and so on. The U in that sequence meant a signal that was 30 times stronger than the background noise. It was a huge spike. The signal lasted for 72 seconds, the exact amount of time the Big Ear could observe a single point in the sky as the Earth turned. It came from the direction of the constellation Sagittarius, and its frequency was 1420 megahertz. This was important. That's the frequency of neutral hydrogen, the most common element in the universe. Scientists had long guessed that if an intelligent civilization wanted to send a signal, they might use this fundamental frequency. Eamon was stunned. He grabbed a red pen, circled the sequence 6CQU5, and wrote, "Wow," in the margin. The name stuck. For decades, astronomers have pointed telescopes back at that same patch of sky, and they have found nothing. The wow signal was a one-time event. It has never been repeated. It has never been explained. It remains the most compelling piece of data we have for a possible extraterrestrial signal. It was a brief, powerful shout from the cosmos that told us something was out there. We just didn't know what. That search for the unknown continues. We haven't found another signal like it. But in our search for other worlds, we found planets. And, some of them are so strange, so unlike anything we ever expected, that they defy our understanding of how a planet should even work. They are the true weirdos of the galaxy. Number 23, a planet raining molten iron. The day side of this planet is over 2,400 degrees Celsius. That is hot enough to vaporize rock and metal. The night side is much cooler, around 1,500 degrees Celsius. This extreme temperature difference creates winds that scream across the planet at thousands of kilometers per hour. These winds carry vaporized iron from the hot side to the cool side. On the cooler night side, this iron vapor condenses into clouds and falls as rain. Not water rain, but drops of liquid iron. The planet is called WASP-76b. It was discovered in 2013 by the Wide Angle Search for Planets, or WASP, project. It is a type of planet known as an ultra-hot Jupiter. It's about the size of Jupiter, but slightly less massive. The reason it's so hot is its proximity to its star. It orbits its star every 1.8 Earth days. Its orbit is so tight that it's tidally locked. This means the same side of the planet always faces the star, just like the same side of our moon always faces Earth. This creates a permanent dayside and a permanent nightside. The discovery of the iron rain was made using an instrument called Espresso on the European Southern Observatory's Very Large Telescope in Chile. Astronomers observed the planet as it passed in front of its star. They analyzed the light from the star that filtered through the planet's atmosphere. This technique is called spectroscopy. Different elements absorb light at specific known wavelengths. It's like a chemical barcode. They looked at the light coming from the evening edge of the planet, the line where day turns into night. They saw the clear signature of iron vapor, but when they looked at the morning edge, where night turns into day, the iron signature was gone. This was the key piece of evidence. It meant the iron existed as a gas on the brutally hot day side. The powerful winds then swept this iron vapor over to the night side. As the atmosphere cooled by 1,000 degrees, the iron could no longer stay as a gas. It condensed into liquid droplets, forming clouds of molten iron. From these clouds, it would rain liquid iron down into the planet's deeper layers. The planet is a massive gas giant so there is no solid surface for this iron rain to land on. It just falls deeper into the scorching hot atmosphere. The star this planet orbits, WASP-76, is hotter and larger than our sun. The planet is being blasted by intense radiation, which is what helps vaporize the metals in its atmosphere. WASP-76b is not just a scientific curiosity, it represents a new class of extreme worlds. It shows us that the chemistry and weather on other planets can be far more alien than we thought possible. We think of weather as wind and rain. On WASP-76b, weather involves vaporized rock and metallic downpours. It is a laboratory for extreme physics, a place that tests the limits of our models of how atmospheres behave under the most intense conditions imaginable. Number 22. A planet that should have been eaten. This planet orbits a dead star. The star is a pulsar, a tiny spinning remnant of a massive star that exploded in a supernova. The planet, named Poltergeist, shouldn't be there. The supernova that created the pulsar should have completely destroyed any planets orbiting the original star. Finding a planet here is like finding a flower growing in the middle of a blast crater. The system is called PSR B1257+12. The pulsar was discovered in 1990 by Polish astronomer Aleksander Wolszczan. He was using the Arecibo radio telescope in Puerto Rico. A pulsar is a neutron star that spins incredibly fast and shoots out beams of radiation from its magnetic poles. As it spins, these beams sweep across space like a lighthouse. From Earth, we detect these beams as regular pulses of radio waves. The timing of these pulses is usually incredibly precise, more accurate than an atomic clock. But Wolszczan noticed something odd about PSR B1257+12. The pulses were not perfectly regular. They were arriving a little early, then a little late in a repeating pattern. The only thing that could cause this was gravity. Something was pulling the pulsar back and forth as it moved through space, and that something had to be planets. In 1992, he and his colleague Dale Frail confirmed the existence of 2 planets. This was a landmark discovery. These were the very first exoplanets ever confirmed. It was a huge moment, but also a deeply confusing one. You know, everyone had been looking for planets around normal sun-like stars. No one expected to find them around a dead one. The 2 main planets were named Poltergeist and Phobator. Poltergeist, or PSR B1257+12, is about 4 times the mass of Earth. Phobator, or PSR B1257+12, a third, much smaller planet Droger, was later found orbiting even closer to the pulsar. These are not gas giants, but rocky terrestrial worlds, but they exist in a terrible environment. They are constantly bathed in intense radiation and high-energy particles from the pulsar. Their life, as we know it, could not survive there. The big question is how they got there. There are 2 main theories. The first is that they are second-generation planets. After the supernova, a disk of debris from the destroyed star and possibly a companion star might have formed around the new pulsar. Over millions of years, this debris could have clumped together to form new planets. They are essentially zombie worlds built from the ashes of the old system. The second theory is that they were the rocky cores of former gas giants. Perhaps they were orbiting far enough away that the supernova blew away their thick gas atmospheres but left their dense cores intact. These cores were then pulled into new, closer orbits around the pulsar. Whatever their origin, the pulsar planets of PSR B1257+12 are thinking. They showed us that planets can form and exist in the most unlikely and hostile places. They were the first proof that our solar system was not the only one, and they did it in the weirdest way possible. They taught us to expect the unexpected in the search for other worlds. Number 21. The planet older than the universe was thought to be. This planet is 12.7 billion years old. It formed just a billion years after the Big Bang. This was a time when the universe was very different. It was metal poor, meaning heavy elements like Carbon and oxygen, which are needed for rocky planets like Earth, were extremely rare. This planet, officially named PSR B162026b, but nicknamed Methuselah, challenges our ideas about when planets could first form. It was discovered in a place you wouldn't expect to find old objects, a globular cluster. These are ancient, densely packed balls of hundreds of thousands of stars. This particular cluster, Messier 4, is about 12.4 billion years old itself. Methuselah orbits a very strange pair of stars. One is a pulsar, a rapidly spinning neutron star. The other is a white dwarf, the dense core of a dead sun-like star. The planet orbits both of them. The discovery was a long process. The pulsar was found in 1987. Soon after, astronomers noticed irregularities in its pulse timing, similar to how the first exoplanets were found. They suspected a companion object, but it took years of observation with the Hubble Space Telescope to confirm it. The final confirmation came in 2003. They had found a planet about 2.5 times the mass of Jupiter. Its age and location are what make it so bizarre. At the time Methuselah formed, the universe consisted almost entirely of hydrogen and helium, the elements created in the Big Bang. Heavier elements, which astronomers call metals, are forged inside stars and scattered into space when they die. These elements are the building blocks of planets like Earth. The fact that a gas giant planet could form so early in a metal-poor environment was a huge surprise. It suggests that planet formation might not require as many heavy elements as we thought. Maybe all you need is a little bit of dust to act as seeds for gravity to start pulling gas together. The planet's history is a chaotic one. It likely did not form around the two stars it now orbits. The current theory is that the planet originally orbited a normal sun-like star. This star and its planet then drifted into the crowded core of the globular cluster. There, it had a close encounter with the binary system containing the neutron star. In a complex gravitational dance, the neutron star kicked out the original companion star and captured the new star and its planet. Later, the captured star evolved, swelled up, and its material was siphoned off by the neutron star, spinning it up into the fast-spinning pulsar we see today, leaving the star's core behind as a white dwarf. So Methuselah is a survivor. It has witnessed the birth of the galaxy, lived through the death of its original star, been captured by a new dead star system, and now resides in one of the oldest and most crowded stellar neighborhoods in the Milky Way. It is a relic from the dawn of the cosmos, a planet that tells us that the story of worlds began much earlier than we ever imagined. Number 20, a world made of diamond. This planet has a surface that may be covered in graphite and a massive interior layer made of pure diamond. It is about twice the size of Earth, but 8 times more massive, making it a super Earth. Its value, if it could be mined, would be in the trillions of dollars, but its scientific value is even greater. It shows us that planets can be made of things we never considered. The planet is 55 Cancri E. It orbits a star called 55 Cancri, which is visible to the naked eye about 40 light years away in the constellation Cancer. It's part of a system with 5 known planets. 55 Cancri E is the innermost one. It orbits its star in just 18 hours. Its surface temperature is estimated to be over 2,000 degrees Celsius. It was first detected in 2004 through the radial velocity method, which measures the wobble of a star caused by an orbiting planet's gravity. But it wasn't until 2012 that a team at Yale University proposed its strange composition. They looked at the mass and radius of the planet and the chemical makeup of its host star. The star has a much higher ratio of carbon to oxygen than our sun. Since planets form from the same disk of material as their star, it stands to reason that the planet would also be carbon-rich. In a normal rocky planet like Earth, the interior is dominated by silicon and oxygen compounds. But in a carbon-rich system, the chemistry is different. The models for 55 Cancri E suggest that instead of a water layer and a silicate mantle, it has an interior with a thick layer of diamond. The immense pressure and heat deep inside the planet would be enough to compress the abundant carbon into a crystalline diamond form. The surface would likely be covered in graphite, which is another form of carbon. The idea of a diamond planet is fascinating, but it's still a model based on the available data. Further observations are needed to confirm it. The James Webb Space Telescope is studying the planet's atmosphere, which could give us more clues about its surface composition. Some recent studies have suggested it might have a thick atmosphere that would make a solid surface impossible to see directly. It might not be a solid diamond ball, but a world with a complex carbon-rich geology unlike anything in our solar system. Even if it's not a perfect diamond sphere, 55 Cancri E forces us to broaden our definition of a rocky planet. We tend to assume other terrestrial worlds are like Earth, with iron cores and silicate mantles. But this planet suggests that the chemistry of the parent star can lead to vastly different planetary compositions. There could be carbon planets, silicon carbide planets, or other exotic types we haven't even thought of yet. It's a reminder that the universe is not just bigger than we imagine, it's more creative. Number 19, the planet with 3 suns in its sky. From the surface of this planet, you would see 3 stars. One would be a large yellow sun. The other 2 would be a pair of smaller red and orange stars orbiting each other. Sometimes you would see all 3 in the sky at once, sometimes one pair would eclipse the other. The sunsets and sunrises would be spectacular and complex events. This world is HD 188,753 Abe. It is located about 150 light-years away in the constellation Cygnus. It is a gas giant, slightly more massive than Jupiter. It orbits its primary star, a star very similar to our Sun, in a blistering 3.3-day orbit. This makes it a hot Jupiter, but what makes it truly unique is its stellar environment. The primary star is not alone, it is part of a triple star system. The other 2 stars are a close binary pair of a yellow dwarf and a red dwarf. They orbit each other every 156 days. This binary pair then orbits the main star and its planet at a distance roughly equivalent to the distance between our Sun and Saturn. The discovery was announced in 2005 by a team of astronomers from Caltech. They found the planet using the radial velocity method at the Keck-I Observatory in Hawaii. The existence of this planet was a major puzzle for planet formation theories. The standard model of how gas giants form is called core accretion. It says that a rocky core of about 10 Earth masses forms first from the protoplanetary disk of gas and dust around a young star. This core then becomes massive enough to gravitationally attract and hold on to a huge amount of gas, forming a gas giant. This process takes a few million years. The problem with HD 188,753 AB is that the powerful gravity of the 2 other stars in the system should have disrupted the protoplanetary disk around the main star. Their gravitational pull would have stirred up the material, making it very difficult for a large planet to form, especially a gas giant that needs a lot of material. The disk would likely have been truncated or cut short, not leaving enough room or raw material for a Jupiter-sized planet to grow. This led to a lot of debate in the astronomical community. Some scientists questioned the discovery itself, suggesting the data could be interpreted in other ways. Follow-up studies have had difficulty redetecting the planet, leading to some controversy over whether it truly exists. If it does exist, it forces us to reconsider how and where giant planets can form. Maybe they can form much faster than we thought, before the companion stars can disrupt the disk. Or maybe they form further out in the disk and then migrate inwards to their current tight orbit. Another possibility is a different formation model entirely, called disk instability, where a massive planet can form directly from a gravitational collapse within the disk, a much faster process. Whether HD 188,753 AB is confirmed or not, the search for it has pushed our understanding. It highlights the challenges of planet formation in complex multi-star systems, which are very common in our galaxy. About half of all sun-like stars are in binary or multiple systems. Finding out if they can host planets and how is a key part of understanding how many potential homes for life might be out there. Number 18, a planet where it rains glass sideways. The sky on this planet is a deep cobalt blue, but this beautiful color comes from a terrifying weather system. The planet has winds that blow at over 8,700 kilometers per hour. That is 7 times the speed of sound. And the rain is not water, it is molten glass blowing sideways in the hurricane-force winds. The planet is HD 189733b. It's one of the most studied exoplanets, located about 63 light-years away. It's a hot Jupiter, slightly larger and more massive than our own Jupiter. It orbits its star in just 2.2 days, so it is also tidally locked. Its temperature is a searing 1,000 degrees Celsius. We know its color because in 2013, astronomers using the Hubble Space Telescope measured the light reflecting off the planet. They observed the system as the planet passed behind its star. By measuring the dip in the total light of the system and what colors of light dipped the most, they could figure out the color of the planet itself. It was the first time the visible color of an exoplanet had been determined. The blue color is not from oceans like on Earth. It is thought to come from silicate particles in its atmosphere. These are the building blocks of sand and glass. The extreme heat of the planet's atmosphere keeps these silicate particles in a molten liquid state. The sideways glass rain is a result of the planet's extreme weather. The incredibly fast winds, measured by observing the Doppler shift in the spectral lines of sodium in the planet's atmosphere, whip these molten glass droplets around the planet at supersonic speeds. So, it's not a gentle rain, it's a storm of tiny flying glass shards moving faster than a speeding bullet. The HD 189733b taught us a lot about the atmospheres of hot Jupiters. In 2007, the Spitzer Space Telescope made the first ever weather map of an exoplanet by observing its infrared light. The map showed a massive hotspot, not directly under the star as expected, but offset by about 30 degrees. This was direct evidence of the powerful winds pushing the hottest part of the atmosphere around the planet. Scientists have also detected carbon dioxide and water vapor in its atmosphere, showing that the basic ingredients for life can exist even in the most hostile environments. But the conditions are far too extreme for life as we know it. HD 189733b, a perfect example of a beautiful but deadly world. It looks like a serene blue marble from a distance, but up close it's a planetary hellscape, a world of perpetual supersonic glass storms. Number 17, the planet made of burning ice. This planet is a world of contradictions. It is a Neptune-sized planet with temperatures over 400 degrees Celsius. But it is largely composed of water. This water, under immense pressure, exists in a bizarre state called hot ice, or ice vesivin. It is a planet of burning ice. Gliese 436b orbits a red dwarf star just 33 light-years from Earth. It was discovered in 2004. It is about 22 times the mass of Earth. It orbits its star in a very tight orbit of only 2.6 days. This close proximity is what makes it so hot, so how can it be made of ice? The answer lies in pressure. On Earth, water freezes at 0 degrees Celsius and boils at 100 degrees Celsius. But this is only true at our atmospheric pressure. If you increase the pressure dramatically, the rules change. The immense gravity of Gliese 436b, due to its high mass, creates crushing pressure in its interior. This pressure is so strong that it forces the water molecules to pack together into a solid form, even at hundreds of degrees Celsius. It's not ice as we know it, which is a crystalline structure, ice-I. It's a different, denser phase of ice, like Ice 7 or Ice X. The planet is thought to have a small, rocky core. Above that is this massive mantle of hot, compressed ice. And on top of that is a steamy atmosphere of hydrogen and helium that is slowly boiling off into space. One of the planet's other mysteries is its atmosphere. Given its size and temperature, it should have a lot of methane, but observations have shown that it has very little methane and a surprising abundance of carbon monoxide. The reason for this chemical imbalance is not fully understood. It might be due to processes deep within the planet's atmosphere, where the hot ice mantle interacts with the upper layers. Gliese 436b has another strange feature its orbit. It passes almost directly over the poles of its star. This is a highly unusual polar orbit. Most planets orbit around the star's equator in the same plane that the star itself rotates. A polar orbit suggests that the planet has had a violent past. It might have been knocked into this strange orbit by the gravitational influence of another, yet undiscovered, planet in the system. Gliese 436b is a fantastic natural laboratory for studying how materials behave under extreme conditions. It forces us to think beyond our everyday experience of solids, liquids, and gases. It shows that on other worlds, even a simple substance like water can exist in forms that seem impossible to us, like a solid block of ice that is hot enough to boil metal. Number 16, the darkest planet found. This planet is blacker than coal. It reflects less than 1% of the light that hits it. This makes it darker than any planet or moon in our solar system. If you were floating in space near it, it would be like looking at a hole in the stars, a lump of pure darkness. The planet is named TRES 2b. It was discovered in 2006 by the Transatlantic Exoplanet Survey TRES. It is a hot Jupiter, about the same size as Jupiter, orbiting a sun-like star 750 light-years away. It orbits its star in just 2.5 days, making it incredibly hot with a temperature of around 980 degrees Celsius. Its extreme darkness was a mystery when it was measured by the Kepler Space Telescope in 2011. Jupiter, for comparison, reflects more than a third of the sunlight that hits it because of its bright, colorful clouds of ammonia. Even a dark, rocky body like our moon reflects about 12% of sunlight. TRES 2b is much, much darker. The reason for its blackness is not that it's just a dark color. The planet is so hot that it glows with a faint red heat, like a hot coal or an electric stove element. The darkness is due to its atmosphere. Scientists believe the atmosphere contains light-absorbing chemicals, and compounds like vaporized sodium, potassium, or titanium oxide could be present in the atmosphere, and these chemicals are very good at absorbing light rather than, scattering it back into space. But even these chemicals don't fully explain the extreme blackness. The planet is darker than our models predict. This suggests there might be other unknown light-absorbing chemicals in its atmosphere. The planet is so close to its star that it's tidally locked, with one side permanently facing the star and one side in darkness. The intense heat from the star might be creating a unique atmospheric chemistry that we don't yet understand. TRES 2b is not just dark, it is unnaturally dark. It challenges our understanding of atmospheric chemistry on hot Jupiters. It shows that there are processes at work on these planets that we have not yet accounted for in our models. It's a reminder that even something as simple as the color of a planet can hold deep secrets about its nature. It's a pitch-black world glowing with its own heat, a true dark star in the catalog of strange planets. Number 15, the puffiest planet. This planet is huge, nearly twice the size of Jupiter, but it has less than half of Jupiter's mass. This means its density is incredibly low. It's so light and airy that it has been compared to styrofoam. If you could build a bathtub big enough to hold it, this planet would float. It is called WASP-17. It was discovered in 2009. It is an inflated gas giant, also known as a puffy planet. It orbits its star, located about 1,300 light years away, in 3.7 days. Its huge size and low mass make it the least dense planet ever discovered. What makes a planet so puffy? The main reason is heat. WASP-17b is very close to its star, so it's very hot. The intense heat from the star causes the planet's atmosphere to expand like a hot air balloon. But heat alone doesn't seem to be enough to explain its enormous size. There must be other mechanisms at work. One theory is tidal heating. WASP-17b is on a slightly elliptical orbit. As it gets closer to and farther from its star, the star's gravity flexes and squeezes the planet. This constant flexing creates friction deep inside the planet, generating a huge amount of internal heat. This extra heat from the inside would cause the atmosphere to puff up even more. Another unique feature of WASP-17b is its orbit. It orbits its star backwards. All the planets in our solar system orbit the sun in the same direction that the sun rotates. This is called a prograde orbit. WASP-17b has a retrograde orbit. It moves in the opposite direction of its star's rotation. It was the first planet discovered with such an orbit. A retrograde orbit is a clear sign of a violent and chaotic past. A planet cannot form this way. It must have been thrown into this bizarre orbit by a powerful gravitational encounter. Perhaps it nearly collided with another giant planet in the system long ago. Or maybe it was part of a binary star system and complex gravitational interactions flipped its orbit. The same violent event that put it on its strange orbit could also be responsible for its puffiness by contributing to the tidal heating. WASP-17b is a puzzle. Its low density and backward orbit are extreme examples of how planetary systems can evolve. It shows that the neat, orderly layout of our own solar system is not the only way things can be. Other systems can be chaotic places where planets get thrown around, flipped over, and puffed up to incredible sizes. It's a testament to the dynamic and often violent nature of planetary evolution. And number 14, the planet with rings 200 times bigger than Saturn's. There is a young star out there with a planet or a brown dwarf surrounded by a colossal ring system. The rings are so vast that if they were placed around Saturn, they would dominate our night sky. They would appear many times larger than the full moon. This system has been nicknamed Super Saturn. The object at the center of the rings is J1407b. It orbits the star J1407, which is a young sun-like star about 434 light years away. The star is only about 16 million years old, a mere infant in stellar terms. We haven't seen J1407b directly. Its presence was inferred by the way it blocked the light from its star. In 2007, astronomers at the University of Rochester were observing the star and saw something incredible. The star's light began to dim in a very strange and complex way. It wasn't the simple, clean dip in light you see from a normal planet transit. The event lasted for 56 days. The light flickered, dimmed, brightened, and dimmed again in a complicated pattern. It was clear that something huge and complex was passing in front of the star. After years of analysis, the team concluded that the only thing that could explain this bizarre light curve was a massive ring system. They modeled a system with over 30 distinct rings, stretching out to a diameter of 180 million kilometers. That's more than the distance from the Earth to the Sun. Saturn's main rings, for comparison, are only about 280,000 kilometers in diameter. The rings of J1407b are not just bigger, they are also much more massive. The total mass of the dust in these rings is thought to be about the same as the mass of the Earth. And there are clear gaps in the rings. These gaps are very exciting to astronomers. They are likely being cleared out by exomoons, moons that are forming within the ring system, just as some of Saturn's smaller moons help shape its rings. One of the gaps is so wide that it might contain a moon as massive as Mars. The central object, J1407b itself, is also a mystery. We're not sure if it's a giant planet or a brown dwarf, which is a failed star that's more massive than a planet, but not massive enough to ignite nuclear fusion. The estimates put its mass somewhere between 10 and 40 times the mass of Jupiter. Because the star is so young, we are getting a snapshot of a planetary system in the process of formation. This is what our own solar system might have looked like over 4 billion years ago, when the planets and moons were still forming from a disk of gas and dust. The rings of J1407b will not last forever. Over the next few million years, the material in the rings will either clump together to form more moons or be blown away by stellar radiation. We are lucky to have caught it in this spectacular, but temporary, phase. Number 13, the pink planet. Astronomers have discovered a planet that is a distinct dark magenta color. It is one of the least massive planets ever to be directly photographed around a star like our sun. Its pinkish hue likely comes from a relatively cloud-free atmosphere, allowing us to see the deep, warm glow from its interior. This planet is GJ504b. It orbits the star GJ504, about 57 light-years away. It was discovered in 2013 using the Subaru telescope in Hawaii. Finding planets by direct imaging is very difficult. Planets don't produce their own light, they only reflect light from their star. And they are incredibly faint and close to their bright parent stars. It's like trying to spot a firefly next to a searchlight. To directly image a planet, astronomers usually look at young star systems. Young planets are still very hot from their formation, so they glow brightly in infrared light. GJ504b is a young planet, part of a system that is only about 160 million years old. This is what allowed astronomers to capture a picture of it. What they found was a gas giant about 4 times the mass of Jupiter. But what really stood out was its color. After analyzing the infrared light from the planet, they determined its appearance in visible light would be a shade of pink or magenta. The color is thought to be a result of its heat and a very clear atmosphere. With fewer clouds in the upper atmosphere to block the view, we are able to see deeper into the planet where the temperatures are higher, resulting in this glowing pinkish color. Its existence also poses a challenge to our theories of planet formation. GJ504b orbits its star at a distance of about 44 times the distance from the Earth to the Sun. That's much farther out than Neptune is in our solar system. The standard core accretion model of planet formation has a hard time explaining how a gas giant could form so far away from its star. At that distance, the protoplanetary disk of gas and dust would have been too thin. There just wasn't enough material for a large rocky core to form quickly enough to then attract a massive gas envelope. This suggests that it might have formed through a different process, like the disk instability model, where a massive planet can form rapidly from the direct collapse of a dense clump of gas in the disk. GJ504b is not just a pretty pink planet, it is a puzzle that forces astronomers to rethink the different ways giant planets can be born, especially in the cold, distant outer reaches of a planetary system. Number 12, the lone wanderer of the galaxy. This planet has no sun, it drifts alone through the cold, dark emptiness of interstellar space. It is a rogue planet, a world that was ejected from its home solar system, and now wanders the galaxy as a perpetual orphan. It will never experience a sunrise or a sunset. Its only light comes from the distant stars of the Milky Way. The planet is called PSO J318.522. It was discovered in 2013 by astronomers using the Pan-STARRS One Wide Field Survey telescope on Maui. They weren't looking for planets, they were looking for brown dwarfs. But this object was different. It was red, much redder than known brown dwarfs, and its infrared signature matched that of a very young, newly formed planet. But it was all by itself with no star anywhere near it. PSO J318.522 is located about 80 light-years from Earth. It is estimated to be about 6 times the mass of Jupiter and only about 12 million years old. Because it is so young, it is still glowing with the heat of its formation, which is how we are able to see it in infrared light. Its temperature is about 800 degrees Celsius. Over billions of years, it will gradually cool down until it becomes a cold, dark ball of gas, almost impossible to detect. How does a planet go rogue? The most likely scenario is that it was formed in a normal planetary system, but then it was kicked out. Early in the life of a solar system, the orbits of the newly formed planets can be unstable. Giant planets can migrate and gravitationally interact with each other. In this chaotic cosmic dance, a smaller planet can be flung out of the system entirely by a close pass with a much larger planet. It's a game of gravitational billiards, and PSO J318 5-22 lost. Scientists estimate that there could be billions or even trillions of these rogue planets wandering our galaxy. Most of them would be cold and dark, making them incredibly hard to find. We can only spot them if they are young and hot, like this one, or if they happen to pass in front of a distant star and briefly magnify its light through a process called gravitational microlensing. The idea of a world without a sun is both lonely and fascinating. Could such a planet harbor life? Without a star for energy, life on the surface would be impossible, but some scientists have speculated that if a large, rocky, rogue planet had a thick hydrogen atmosphere, it could trap enough of the planet's internal heat to keep liquid water on its surface. Or, if it had a subsurface ocean like Jupiter's moon Europa, life could potentially exist around hydrothermal vents powered by the planet's own geothermal energy. It's a long shot, but the existence of rogue planets opens up a whole new category of potential habitats in the galaxy. Number 11, the planet with a giant comet-like tail. This planet is so close to its star that its atmosphere is being boiled away into space. The stellar wind is stripping away the planet's atmosphere, creating a massive, invisible tail that trails behind it like a comet. The planet is literally evaporating. The world is HD 209,458b, nicknamed Osiris after the Egyptian god of the afterlife. It was a groundbreaking discovery in many ways. Found in 1999, it was the first planet discovered using the transit method, where astronomers watch for the slight dip in a star's light as a planet passes in front of it. It was also the first exoplanet where an atmosphere was detected. Osiris is a hot Jupiter, about 70% the mass of Jupiter. It orbits its sun-like star at a distance of only 7 million kilometers, which is about 1/8 the distance of Mercury's orbit in our solar system. Its year lasts just 3.5 Earth days. Because it is so close, its atmosphere is heated to over 1,000 degrees Celsius. In 2003, astronomers using the Hubble Space Telescope made a remarkable discovery. They were studying the planet's atmosphere by looking at the starlight that passed through it. They found the chemical signatures of hydrogen, carbon, and oxygen, but the hydrogen signature was huge. It formed a massive extended envelope around the planet, an exosphere that was being blown back by the intense radiation and stellar wind from the star. This cloud of escaping hydrogen forms a giant tail. We can't see it with a normal telescope, but if we could, it would look like the planet was a giant comet. The planet is losing its atmosphere at a rate of at least 10,000 tons per second. This sounds like a lot, but the planet is so massive that, even at this rate, it will survive for billions of years. It is not in immediate danger of evaporating completely, so the study of Osiris's atmosphere has been a gold mine for astronomers. It was the first place outside our solar system where water vapor was identified. Scientists have also found traces of carbon monoxide and sodium. By studying how this atmosphere is being stripped away, we can learn a lot about the interactions between stars and their close-in planets. Osiris is an example of what can happen to a gas giant that gets too close to its star. It represents a, class of planets called hot Jupiters that are slowly being eroded by their parent stars. It provides a real-world example of atmospheric escape, a process that is crucial for understanding how planets, including our own, evolve over time and whether they can hold on to the atmospheres necessary for life. Number 10, the planet that orbits two stars. This is a real-life Tatooine. It is a planet that orbits two suns. From its surface, you would see a double sunset with a larger yellow star and a smaller red star setting one after the other. It is a circumbinary planet, a world that has proven that science fiction can become scientific fact. The planet is Kepler-16b. It was discovered in 2011 by the Kepler Space Telescope. Kepler worked by staring at a patch of sky with over 150,000 stars and looking for the tiny periodic dips in starlight caused by transiting planets. The Kepler-16 system was unusual. The two stars, a K-dwarf and a red dwarf, orbit each other every 41 days, and Kepler saw them regularly eclipsing each other, but then it saw extra smaller dips in the light. These extra dips were caused by a planet. Sometimes the planet would pass in front of the larger star, sometimes it would pass in front of the smaller star, and sometimes both stars would be blocked by the planet at the same time. The timing of these transits was complex, but it allowed astronomers to confirm with 100% certainty that there was a single planet orbiting both stars. Kepler-16b is a cold Saturn mass gas giant. It orbits its two parent stars every 229 days at a distance similar to that of Venus in our solar system. Because its stars are smaller and cooler than our sun, the planet is quite cold, with a surface temperature of around 70 to 100 degrees Celsius. It is likely not a habitable world. The existence of Kepler-16b was a major discovery. Before this, astronomers weren't sure if stable planetary orbits could exist around a close binary star system. The complex and shifting gravitational fields of two stars could easily disrupt a forming planet or fling it out of the system. Kepler-16b proved that stable circumbinary orbits are possible. It likely formed in a large disk of gas and dust that surrounded both stars. Since the discovery of Kepler-16b, the Kepler mission has found a dozen more circumbinary planets. These Tatooine worlds are no longer just science fiction. They are a recognized class of planets. They show us that planets can form and thrive in even the most gravitationally complex environments. And it expands the range of places where we might search for planets and perhaps one day for life. It reminds us that the universe is full of different types of solar systems, many of which look nothing like our own. Number 9, the planet shaped like an egg. This planet is being stretched into the shape of an egg by the immense gravity of its star. It is also one of the hottest and shortest-lived planets we have ever found. It is so close to its star that it is being slowly torn apart and consumed. The planet is WASP-12b, discovered in 2008. It is a hot Jupiter, about 1.4 times the mass of Jupiter. But what is truly extreme is its orbit. It whips around its star in just over one day. This incredibly tight orbit means it is subjected to massive tidal forces. The star's gravity pulls much more strongly on the side of the planet facing it than on the far side. This constant stretching has distorted the planet from a sphere into a prolet spheroid, an egg-like shape. The planet is also incredibly hot, with a dayside temperature of over 2,200 degrees Celsius. This intense heat, combined with the tidal forces, is causing the planet to lose its atmosphere at a staggering rate. The material is being pulled directly off the planet and is forming a disk of gas around the star. The planet is being cannibalized by its parent star. Astronomers estimate that it has a remaining lifetime of only about 10 million years, a mere blink of an eye in cosmic terms. WASP-12b is also one of the darkest planets known, similar to Trieste-2b. It reflects very little light. The reason for its darkness is its heat. Its atmosphere is so hot that molecules like hydrogen are broken down into their atomic forms, which are very good at absorbing light. The composition of WASP-12b's atmosphere is also unusual. In 2017, observations with the Hubble Space Telescope showed that it has a surprisingly high amount of carbon. In fact, the carbon-to-oxygen ratio appears to be greater than 1. This makes it a carbon-rich planet. This high carbon content might mean that the planet's core could be made of diamond or graphite, similar to the theories about 55 Cancri. WASP-12b is a planet on death row. It gives us a fascinating, if grim, look at the end-of-life process for a planet that gets too close to its star. And we are watching a world being actively destroyed, its stretched shape, its dark, carbon-rich atmosphere, and its ultimate fate make it one of the most extreme and weirdly compelling planets we have ever found. Number 8, the potential water world. This exoplanet could be a water world, a planet completely covered by a deep global ocean. It is larger than Earth, but smaller than Neptune, placing it in the category of super Earth or mini Neptune. Its low density suggests it is not a rocky planet, but one composed of a significant amount of water. The planet is GJ1214b. It was discovered in 2009 by the Earth Project, which searches for planets around nearby M-dwarf stars. It orbits a red dwarf star just 47 light-years away. The planet is about 2.7 times the diameter of Earth and about 6.5 times its mass. It orbits its star very closely with a year that lasts only 1.6 Earth days. Because of its close orbit, the planet is hot, with an estimated temperature of around 230 degrees Celsius. This is too hot for liquid water as we know it on the surface. However, the initial data on its mass and radius suggested a very low density. It was much too light to be purely rock, but much too dense to be a gas giant like Jupiter. The best explanation was that a large fraction of its mass is water. Astronomers used the Hubble Space Telescope to study its atmosphere. They hoped to find a clear signature of water vapor. What they found instead was. It suggested that the planet is shrouded in a thick layer of clouds or haze high in its atmosphere. These clouds are blocking the light and preventing us from seeing the composition of the atmosphere underneath. The current model for GJ1214b is that it is a world with a small, rocky core surrounded by a massive ocean. Because of the high temperature and pressure, this water would not be like the oceans on Earth. It would exist in exotic forms, possibly a supercritical fluid, which is a state of matter that is not quite a liquid and not quite a gas. The atmosphere above this ocean would be very steamy and thick, full of the very clouds that are preventing us from getting a clear look. GJ1214b represents a new kind of planet, one that is not common in our own solar system. We have small, rocky planets and large gas giants, but nothing in between. Mini-Neptunes, like GJ1214b, seem to be very common in the galaxy. Understanding them is crucial to understanding the full diversity of planets out there. Whether it is a true water world or something else entirely, GJ1214b is a prime target for the James Webb Space Telescope, which might be able to peer through its clouds and finally reveal the secrets of this steamy, mysterious world. Number 7, a planet with an iron heart and an iron sky. This planet is so close to its star that its surface is a sea of molten lava. Its year is less than 9 hours long. It is so hot that its rocky surface vaporizes, creating a thin, temporary atmosphere made of metal and rock vapor. It is one of the densest and fastest orbiting planets ever found. The planet is Kepler-78. It was discovered in 2013 by the Kepler Space Telescope. It is an Earth-sized planet, only about 20% larger than Earth. But what was truly shocking was its orbital period. It orbits its star every 8.5 hours. To do this, it has to be incredibly close to its star, at a distance of only about 1.5 million kilometers. This is about 40 times closer than Mercury is to our Sun. Because of this proximity, its surface temperature is estimated to be between 2000 and 2800 degrees Celsius. At these temperatures, the rock on its surface would be molten. The planet is likely a churning ball of lava. The intense radiation from the star would also vaporize the rock, creating a fleeting atmosphere of silicon, oxygen, and iron vapor. The biggest surprise came when astronomers measured its mass. They used the radial velocity method to find that it is about 1.7 times the mass of Earth. Since its size is only slightly larger than Earth's, this means its density is very similar to Earth's. This was a crucial finding. It suggests that Kepler-78b, despite its hellish environment, has a composition similar to Earth, a mix of rock and iron, likely with a large iron core. It was the first Earth-sized exoplanet for which both the mass and radius were accurately measured. The existence of Kepler-78b is a complete mystery. How did it get there? A planet cannot form that close to its star. The temperatures are too high for material to condense, and the gravitational environment is too chaotic. It must have formed farther out and then migrated inwards. But what stopped its migration? Why didn't it just spiral all the way into its star? The forces that govern planetary migration are not well understood, and Kepler-78b is a major puzzle for theorists. Like WASP-12b, Kepler-78b is also doomed. The same tidal forces that likely circularized its orbit will eventually cause it to spiral into its star and be destroyed. It has a predicted lifetime of only a few 100 million years. Kepler-78b is a glimpse into a truly alien geology. It's a rocky world, but one where the rock cycle involves melting, vaporizing, and raining back down as molten droplets. It is a world of fire and brimstone that challenges our most basic ideas of where a planet can exist. Number 6, the planet in a quadruple star system. Some planets have one sun, some have 2 or even 3. This planet has 4. It exists in a complex and stable orbit within a system of 2 pairs of binary stars. The sky on this world would be a dizzying display of 4 suns of different sizes and colors, moving in a complex celestial dance. The system is called 30 Arietis. It's located about 136 light years away. For years, astronomers knew it was a multiple star system. There is a main star, 30 Arietis b, which is a yellow-white dwarf. This star has a planet discovered in 2009 called 30 Arietis bb. This planet is a massive gas giant, about 10 times the mass of Jupiter, and it orbits its star in a nearly year-long orbit. The complexity comes from the other stars. The star 30 Arietis b is itself a binary. It has a very close companion star that orbits it, so the planet actually orbits the main star of a close binary pair. But that's not all. Farther away, at a distance of about 23 times the distance from Pluto to our Sun, is another pair of stars, 30 Arietis A and 30 Arietis C, which form another binary system. This second binary pair then orbits the first binary pair, so altogether you have a planet orbiting one star, which has a companion star, and this whole setup is being orbited by another pair of stars. The discovery that the planet was in a quadruple system was made in 2015 when a team of astronomers was examining data from a survey and realized that the main star had a previously unknown stellar companion. It was a surprise, as stable planetary orbits in such complex systems were thought to be rare. The gravity from 4 different stars could easily perturb a planet's orbit and eject it from the system. Yet, 30 Arietis bb seems to be in a stable, long-term orbit. This is likely because of the hierarchical nature of the system. The planet orbits its primary star very closely. The companion to that star is also very close. The other binary pair is very, very far away. This separation of scales allows the planet's orbit to remain stable. The gravitational pull from its host star dominates its motion, and the other 3 stars just provide a gentle, long-term tug. This system shows that planetary systems can be far more complex than our own. It tells us that we should not rule out looking for planets in multiple star systems even those with 4 stars. The sky on 30 Ariatis BB would be unlike anything we could imagine. 2 bright suns would dominate the day, while 2 more distant suns would look like incredibly bright stars, all moving in different paths across the sky. Number 5, the planet that is unimaginably fast. The fastest planet in our solar system is Mercury, which completes an orbit in 88 days. There is an exoplanet that completes its orbit in just over 4 hours. Its year is shorter than a movie. It moves through space at a blistering speed of hundreds of kilometers per second. The planet is K2-137b. It's a super-Earth about 1.5 times the size of our planet, orbiting a red dwarf star. It was discovered by citizen scientists in 2017 who were poring over public data from the Kepler Space Telescope's K2 mission. They noticed the incredibly short, repeating transits. The official name is EPIC 246,393,474b, but K2-137b is more common. Its orbital period is just 4.3 hours. This is the shortest orbital period ever found for a planet around a normal star. To move this fast, it has to be incredibly close to its star's surface. It is so close that it is likely within the star's Roche limit, the distance at which a planet's own gravity is overcome by the star's tidal forces, and the planet should be torn apart. So why is it still there? One possibility is that the planet is much denser than we think. If it has a massive iron core, its own gravity might be strong enough to hold it together against the star's tidal forces. It would have to be an iron planet, a world made almost entirely of metal. Another theory is that it is the remnant core of a much larger gas giant. Perhaps it was once a hot Jupiter that migrated inwards and had its gassy atmosphere completely stripped away by the star, leaving only its dense, rocky core behind. This Thonian planet would be tough enough to survive in such an extreme orbit. Life on K2-137b is impossible to imagine. It would be tidally locked, with one side perpetually baked by the star's intense radiation at a distance that makes Mercury's orbit look like the outer solar system. The day would last forever, and the year would be over in the time it takes to have lunch. The planet is a blur, a world living its entire existence in the fast lane right on the edge of destruction. Its discovery pushes the limits of how close a planet can get to its star and still survive. Number 4, the planet that creates its own weather. This brown dwarf, a massive object that blurs the line between a planet and a star, has weather patterns that are unlike anything we've ever seen. It has giant planet-sized storms, but these storms are not made of water clouds. They are made of molten iron and silicate dust, and the planet's own rapid rotation and internal heat drive this bizarre weather. The object is Lumen 16b. It is part of a binary system of 2 brown dwarfs, Lumen 16a and 16b, discovered in 2013. They are the closest brown dwarfs to our solar system, only 6.5 light years away. Brown dwarfs are often called failed stars because they are more massive than planets, but not massive enough to sustain hydrogen fusion in their cores. Lumen 16b is the more interesting of the two. Astronomers noticed that its brightness was changing rapidly and periodically as it rotated. This meant that the surface was not uniform. It had bright and dark patches, just like Jupiter has its Great Red Spot. By using advanced techniques with the Very Large Telescope in Chile, they were able to create a rough weather map of its surface. The map revealed huge, dark storm systems. The temperature on this brown dwarf is over 1,000 degrees Celsius. At these temperatures, materials that are solid rock on Earth, like silicates, and metals, like iron, are vaporized. They exist as a gas in the atmosphere. In the cooler, higher layers of the atmosphere, these materials can condense to form clouds. So the weather on Lumen 16b is a cycle of raining molten iron and hot sand. The storms are driven by the object's internal heat and fast rotation. Unlike a planet, which gets most of its heat from a star. A brown dwarf generates its own heat from gravitational contraction. This heat from below, combined with a rotation period of just a few hours, creates powerful atmospheric convection and massive swirling storms. Lumen 16b gives us a unique window into the atmospheric dynamics of objects that are in between planets and stars. The weather patterns are similar in structure to those on Jupiter, but the chemistry is far more extreme. It is a world where geology and meteorology are one and the same. The clouds are made of rock, the rain is liquid metal, and the storms are large enough to swallow the Earth. Number 3, a planet orbiting a star that is almost gone. This planet orbits a star at the very end of its life. The star is a tiny, incredibly dense white dwarf. The planet is a gas giant, and its presence there is a mystery. It survived the star's red giant phase, a violent process that should have engulfed and destroyed it. It is a survivor, a ghost of a planet orbiting the corpse of its sun. The system is WD 1850-6534. The white dwarf was known for a long time, but in 2020, NASA's TESS Transiting Exoplanet Survey satellite detected a planet passing in front of it. The planet WD 1856b is about the size of Jupiter, but could be up to 14 times as massive. What is astounding is its orbit. It whips around the tiny white dwarf every 1.4 days. A white dwarf is the remnant core of a star like our sun after it has exhausted its nuclear fuel. Before it becomes a white dwarf, the star swells up into a red giant. Our own sun will do this in about 5 billion years, and its outer layers will expand to engulf Mercury, Venus, and possibly Earth. The star that became WD 1856 would have done the same. Any planet orbiting as closely as WD 1856b now would have been inside the star and vaporized. So how did the planet survive? It must have started its life much farther out, at a safe distance from the star. Then, after the star had shed its outer layers and shrunk down into a white dwarf, something must have happened to send the planet careening inwards. The most likely cause is a series of gravitational nudges from other, more distant objects in the system. There could be other giant planets, or even another star, in a wide orbit. Over millions of years, these objects could have destabilized WD 1856b's orbit and sent it on a path that ended up in its current tight embrace with the dead star. This discovery is important because it shows that planets can survive the death of their stars and end up in new stable orbits around the stellar remnants. It also gives us a glimpse into the far future of our own solar system. If Jupiter is nudged in just the right way by the other outer planets after our sun becomes a white dwarf, it could potentially migrate inwards to a close orbit. WD 1856b is the first intact planet to be found orbiting a white dwarf. It opens up a new frontier in the search for planets. White dwarfs are common, but they are very faint, making them difficult to study. This discovery suggests that many of them might still have planetary systems, ghostly remnants of the systems that existed when the star was alive. Number 2, the planet that rains sunscreen. On the day side of this hot Jupiter, the atmosphere contains titanium oxide, the active ingredient in many sunscreens. This compound creates a thermal inversion layer, or a stratosphere, where the upper atmosphere is hotter than the lower atmosphere. On the night side, this titanium oxide snows out of the atmosphere into the planet's interior. The planet is Kepler 13a. It is a massive gas giant, about 6 times the mass of Jupiter, orbiting very close to its A-type star, which is much hotter and larger than our sun. The planet is one of the hottest known, with a dayside temperature of nearly 2,800 degrees Celsius. It is tidally locked, so one side always faces the star. The presence of a stratosphere was a significant finding. On Earth, our stratosphere is created by ozone, which absorbs ultraviolet radiation from the sun and heats the upper atmosphere. On a hot Jupiter, scientists predicted that heat-absorbing molecules like titanium oxide could do the same thing. Kepler 13a was the first planet where this process was clearly observed. The Hubble Space Telescope was used to measure the temperature of the planet's atmosphere at different altitudes. It found that the dayside atmosphere was indeed hotter at higher altitudes, but on the night side, this temperature inversion was gone. The atmosphere was cooler at higher altitudes, just as you would expect. This difference between the day and night sides revealed the planet's strange weather cycle. The strong gravity of the planet confines the titanium oxide gas to the day side. It absorbs sunlight and heats the upper atmosphere, but powerful winds then blow this gas around to the night side. The night side is much cooler, and the titanium oxide condenses into crystalline flakes. It's a kind of mineral snow. This snow then gets caught in powerful downdrafts and falls deep into the planet's interior. This process is called a cold trap. The titanium oxide is effectively removed from the atmosphere on the night side, so it cannot be blown back around to the day side. This means the planet is constantly pulling its own sunscreen out of the atmosphere on the cold side. This is why the stratosphere only exists on the day side. Kepler 13ab provides a fantastic laboratory for studying how atmospheres on extreme planets work. It shows how the presence of a single molecule can dramatically change the structure and climate of a world. It's a planet with a built-in sunscreen on one side and a perpetual exotic snowstorm on the other. Number 1, the first planet found. The very first exoplanet to be discovered around a sun-like star was a complete shock. It was a giant planet, half the mass of Jupiter, but it orbited its star in a blistering 4.2 days. It was closer to its star than Mercury is to our sun. Nothing like it existed in our solar system, and its discovery completely overturned our theories of how planets form and evolve. The planet is 51 Pegasi b, later officially named Dimidium. It was discovered on October 6, 1995, by Swiss astronomers Michel Mayor and Didier Queloz at the Haute-Provence Observatory in France. They were using a new, highly sensitive spectrograph to look for the tiny wobble in a star's light caused by the gravitational pull of an orbiting planet. When they looked at the star 51 Pegasi, a sun like star 50 light years away, they found a clear, periodic wobble. But the period was incredibly short. At first, they thought it must be a mistake. Our solar system has small, rocky planets close to the sun and giant gas planets far out. Our theories of planet formation were built around this model. Gas giants were supposed to form in the cold outer regions of a solar system where ice could condense and help build a large core quickly. They were not supposed to be found hugging their parent star, but the data was undeniable. After checking and rechecking, they announced their discovery. It was met with a lot of skepticism at first. But within a few weeks, an American team confirmed the planet's existence. The field of exoplanet astronomy was born. The discovery of 51 Pegasi b opened the floodgates. It showed that hot Jupiters, as they came to be called, were common. The existence of hot Jupiters forced a major revision of planet formation theory. The idea of planetary migration became central. Planets do not necessarily stay in the orbit where they form. Their gravitational interactions with the protoplanetary disk of gas and dust can cause a giant planet to spiral inwards, moving from the cold outer regions to a blazing hot orbit close to its star. Or it showed us that our own solar system is not the template for the rest of the galaxy. The universe is filled with a wild and wonderful diversity of worlds, many of them far stranger than we had ever dared to predict. For their groundbreaking discovery, Mayor and Queloz were awarded the Nobel Prize in Physics in 2019. It all began with one weird world that shouldn't have been there, a planet that kicked open the door to a whole new cosmos.